Have you ever wondered how does light look while traveling in space? We can see aeroplanes, spaceships, rockets, satellites traveling from one point to another. But how about light? It's impossible to see the light traveling because of its enormous speed. However, we will make it possible, and we'll show you how the light appears when it travels in the universe. So stay with us while we present you with this amazing simulation. Let's start our animation by representing the actual scale, which means that we are not fast-forwarding the time. A second in our animation will denote the actual second. As soon as we make it realistic, we can see that the planets are now rotating at their real speed around the sun. That is why they appear to have stopped moving. They are moving realistically now, which means Earth would take 365 days now to complete this trip around Sun. We are now emitting the light particles from the Sun. Let's see how they appear while traveling in the universe. Let's zoom out the video a little. As you can see, the light has started its journey, and now it's approaching the planet Mercury, which is the closest planet to the Sun. As you can see, the light is slowly heading towards the planet Mercury now. The speed looks really slow, even though this is the fastest known speed in universe. It's so slow that to even reach out the closest planet, Mercury, it will take around 3 minutes and 13 seconds. So, stay tight and enjoy the video. We'll talk about some facts about light on and off in the video. The speed of light is approximately 186,282 miles per second, or about 299,792 kilometers per second. The small dots that you see in the background of the screen are the distant stars and galaxies which are millions and millions light years away from Earth. The light from these faint stars might have traveled for millions of years to reach our planet. As we are seeing the snapshot of these stars from millions of years in the past, who knows if these stars exist anymore or not? This is quite intriguing. One of the most groundbreaking aspects of the speed of light is its invariance, meaning it remains constant regardless of the motion of the observer or the source. This principle is a fundamental tenet of Einstein's theory of special relativity. In 1905, Albert Einstein formulated his special theory of relativity, which introduced the concept of the speed of light as an unchanging constant. According to this theory, as an object with mass approaches the speed of light, its relativistic mass increases, and the energy required to accelerate it further also increases, making it impossible to reach or exceed the speed of light. Light exhibits both wave-like and particle-like properties. This phenomenon is known as wave-particle duality. It can behave as electromagnetic waves or as discrete packets of energy called photons. Photons, which make up light, are massless particles. They have no rest mass, and they always travel at the speed of light. Light is the fastest known entity in the universe. Nothing can exceed or match its speed. As you can see, light has already reached Mercury now. It took it 3 minutes and 13 seconds. Now it will proceed to its next destination, which is Venus. It takes light to reach Venus in approx 6 minutes from Sun, and from Mercury to Venus in almost 2 minutes, 45 seconds. The speed of light represents a universal speed limit. Nothing with mass can travel faster than light in a vacuum. This law has far-reaching implications for our understanding of the universe, as it imposes constraints on space travel, communication, and the fundamental nature of space-time. Einstein's theory of general relativity expanded on the special theory by describing gravity as the warping of space-time by mass. The speed of light remains a constant even in the presence of massive objects like stars and black holes. It's this framework that has allowed scientists to make accurate predictions about the behavior of light in gravitational fields. The finite speed of light has profound implications for our study of the universe. When we look at distant objects in space, we are, in essence, looking back in time. For example, when we observe the light from a star that is 1,000,000 light-years away, we are seeing that star as it was 1,000,000 years ago. Einstein's famous equation, E is equal to mc squared, demonstrates the equivalence of mass and energy and emphasizes the crucial role of the speed of light. It shows that a small amount of mass can be converted into a large amount of energy, as long as it is multiplied by the speed of light squared. We'll come back to the discussion related to the facts about light, but let's just take a look at the light on the screen. It's the fastest in universe, and yet it seems super slow in astronomical distances. It is looking so slow that I am getting a little impatient now. But stay put, as we see the light is about to reach Venus, which is Earth's sister planet. Venus is the hottest planet in our solar system. Its thick atmosphere is full of the greenhouse gas carbon dioxide, and it has clouds made up of sulfuric acid. It's amazing to see that the light particles are spread across the sun and move outward in all the directions. Every second sun is releasing countless photons, which then traverse the cosmic journey on their own. If you observe, it has been almost 6 minutes that the light has left the sun, and now it has reached the planet Venus. And now, finally, its journey starts to the home planet Earth. It takes around 8 minutes and 20 seconds for the light to reach Earth from sun. The particles of this light will continue to flow in the eternal universe, and who knows which planet or object these particles would collide with to end their journey. We can see that the light is now constantly moving towards Earth. Our existence looks so tiny in front of the vast cosmos. Our solar system and Earth, even though they are huge in size, look so tiny on the cosmic scale. Sometimes my mind resists to believe that light is the fastest thing in the universe. Because if you see, this appears so slow that the interstellar communication cannot practically happen at this pace. If, in future, we have to make interstellar travel possible, we might have to think beyond the speed of light. But that is quite unimaginable, as the most modern spaceships currently fly at a very low speed comparatively. The fastest spaceship is the Parker Solar Probe, which can travel 163 kilometers per second, which is just 0.0005% the speed of light. Anyways, let's just take a look at the screen and try to understand the sheer scale of solar system. All the planets and beyond that, the Oort cloud. It's so huge that the Voyager spacecraft launched in 1977 has just covered a distance of 23 billion kilometers till now. But still, it is not expected to cross the outer boundary of our solar system, the Oort cloud, in another 30,000 years. Let's not forget that it is traveling at an amazing speed of 17 kilometers per second. But as we know, this speed is nothing in comparison to the speed of light. It's been 8 minutes already, but the light hasn't reached our planet yet. It's moving slowly through the empty space occupying our solar system. Imagine putting this on cosmic distances between stars. It takes years and years to cover the distances between stars. As we can see, the light has now reached Earth after completing 8 minutes and 20 seconds journey from the sun. The light still looks so slow. This puts things into perspective and shows how vast this whole universe is, and how even a travel at the speed of light is not going to help if we need to explore the cosmos. In this simulation, the distance between sun and different planets is exactly the same as how it is in real world. From here, the light will flow to the subsequent planets like Mars, Jupiter, Saturn, Uranus, Neptune. Beyond this, the light will continue to flow and will reach Oort cloud, which is supposed to be the outer boundary of our solar system. It is so far that I will have to put this video on for continuously 2 years. Only after that, the light can be assumed to have crossed our solar system. puts the things into perspective, right? But the journey of light will not end there. In the eternal flow of time, the light will continue to flow in the universe and will disappear somewhere in the waves of time. Before we end the video, we want to show you the perspective if we travel at 100 times the speed of light. Let's see how it looks on that scale. As you can see, the moment it left the sun, it reached Earth within a second, and while we are talking here, the light is already on its way near Jupiter. But look at the vastness of our solar system, that even with this speed, light has still not reached all the planets. Even at this speed, I am getting a little impatient to see when will it reach Neptune. Let's wait a bit and experience this unfathomable journey. As you can see, the light has finally reached Neptune after we increased the speed by 100 times. Even at this speed, it will take it around 15 days to reach our next closest star, Alpha Centauri. I hope that this video gave you an insight on how the speed of light looks on the cosmic scale. Stay tuned for more such amazing videos, and do not forget to subscribe to our channel. We'll see you in the next video. Thanks for watching.